Assalamualaikum and hi to everyone. We are from Group 9 and today our group will be presenting factor affecting glass formation. Our group consists of 6 members: NURUL Dania, Nur Sofia, ERFAN Iskandar, Muhammad AFIF, Sharifah Sofia and AININ Sofia. There are 6 learning points that we will cover in this presentation, which are introduction, process of glass formation, factors affect glass formation, industrial relevant and limitation, critical thinking and engineering discussion, and lastly conclusion. So let's start.
I will begin by introducing the concept of glass formation. Glass formation is the process where a liquid cools and becomes a solid without forming a regular crystal structure. As the temperature decreases, the atoms lose their mobility and become fixed in place before they can arrange into an ordered pattern. Because of this, glass forms an amorphous structure rather than a crystalline one. Even though its atoms are arranged randomly, glass still behaves like a solid. It is rigid, transparent, and resistant to corrosion. These properties make glass very useful in industry such as construction, electronics, and optical fibers. Now, let's take a look at the differences between amorphous and crystalline materials. Amorphous glass has a random atomic arrangement, no long-range order, and no sharp melting point. In contrast, crystalline materials have an ordered structure, long-range order, and a sharp melting point. Amorphous glass is usually transparent, while crystalline materials are often opaque and less transparent. Common examples of amorphous glass include fused silica, borosilicate glass, and soda lime glass.
Now we are moving to the process of glass formation. Glass formation starts when the raw material are heated until they melt and become a molten liquid. During cooling, while the material cools, the atom begin to lose energy. So the final structure can be determined by the cooling rate, whether it's too quick or too slow. If the material is cooled very quickly, the atoms do not have enough time to arrange into an ordered crystal structure. So an amorphous glass is formed. However, if the cooling rate is too slow, the atoms have enough time to organize into an regular crystal lattice, resulting in a crystalline solid instead of glass. In this slide, I'll be explaining the diagram on the left and the graph on the right. So let's look at the diagram first. We can clearly see that a slow cooling results in producing crystalline structure, while a rapid cooling forming an amorphous structure that we can call as glass, showing that cooling rate is one of the most important factors in determining the final structure of a material. Now let's look at the graph on the right. So the x-axis represents temperature while y-axis represents volume. So during heating, the material expands and eventually become a liquid that is completely molten. So when the material is cooled slowly, the atom will have enough time to arrange into an ordered crystal structure. However, during rapid cooling, crystallization is avoided and liquid enters a supercooled liquid region before reaching the glass transition temperature known as TG. At TG, the material gradually transforms into a rigid glass without forming crystal. So from the graph, we can see that rapid cooling prevents crystal formation and promotes glass formation.
About 3 factors affecting glass formation. First is cooling rate. Increasing the cooling rate avoid the growth of the crystalline phase from molten melters. The critical cooling rate is the most significant preparation component because it directly controls the microstructure and deformation behavior. A faster cooling rate causes a shorter solidification time and rapid loss of the capacity of liquid atom to rearrange, yielding an unbalanced frozen solid state. In contrast, a slower rate of the cooling provides the atom with more time to reach their equilibrium position. Next is viscosity. Viscosity increases rapidly as liquid cools, reducing atomic mobility and preventing atoms from rearranging into crystalline structure. High viscosity near the glass transition temperature show atomic diffusion and structural relaxation. Viscosity controls crystallization kinetic by limiting crystal nucleation and growth. Viscosity depends on temperature, thermohistoric pressure, by changing how easily the liquid flows. Lastly is crystal nucleation and growth. Crystal nucleation is formation of tiny crystal nuclei in the liquid. Crystal growth occurs because atoms continue to attach to this nuclei, making the crystal larger. Slower nucleation and crystal growth increase glass forming ability by preventing crystallization during cooling. Suppressing both processes allows the liquid to solidify into amorphous glass instead of crystalline material.
Okay, now we move to industrial level and limitation. These 2 points are related because without knowing the limitation of an element, we cannot use it for product because we don't know is it compatible for the product or not. The limitation for glass is brittle, high melting temperature, and lastly, difficult and expensive to shape into complex form. What industry relevant to glass? The industry relevant for glass is construction industry such as windows and doors. The second one is packaging industry, which is bottle and jar. The lastly is electronic. For example, phone screen and display panel. This industry choose this material because it is high melting temperature, because it cannot melt in normal temperature. That's why it's suitable for windows, jars, which is in a room temperature. Even is a hot season, it's still not melting.
Hello, so for now I will explain about the critical thinking and engineering discussion of glass formation. So how does the glass form? The glass formation is mainly controlled by cooling rate. When the molten material cools slowly, the atoms have enough time to arrange themselves into a regular ordered pattern. As a result, a crystalline structure is formed. However, when the material is cooled rapidly, the atoms lose their ability to move before they can organize themselves and become trapped in random arrangement. And then it will produce as an amorphous structure, which is what we call glass. This shows that glass formation depends on how quickly the material cools rather than its composition. Next, let's look at what happened to the atom during cooling. At high temperature, atoms have high energy and move freely in the liquid state. As the temperature decreases, the atoms need to diffuse and rearrange themselves to form a crystal. However, if cooling happens too quickly, atomic movement slows down significantly, and there is not enough time to crystallization to occur. Instead, the atoms become frozen in their random position, resulting in formation of glass. From an engineering perspective, controlling this process is very important. Engineers can control the cooling rate during manufacturing to produce either crystalline material or glass depending on the required application. Engineers can also modify the composition of the material by adding substances such as sodium oxide or calcium oxide. These additives reduce the melting temperature and improve the workability of the glass, making it easier to manufacture product with consistent quality. Different manufacturing techniques are also used to control cooling. For example, the float glass process produces smooth, flat glass for windows, while the fiber drawing process rapidly cools molten glass to produce strong glass fibers for communication system. Finally, understanding glass formation is important because it has many engineering applications. Glass is widely used in building windows, laboratory equipment, optical fibers, and smartphone screens because of its transparency, durability, and also resistant to corrosion.
In conclusion, glass formation is a process where a liquid cools and becomes solid without forming crystals, resulting in amorphous materials. The quality of glass depends on several factors such as the cooling rate, melt viscosity, and materials composition. These factors are important because they affect the strength, durability, and overall performance of the final glass product. Glass is widely used in many industries, including construction, electronics, healthcare, and the automotive industry. However, it also has some challenges such as brittleness, high production costs, and high energy consumption. Therefore, researcher and engineer continue to develop new technologies and improve glass composition to make glass stronger, more sustainable and more efficient for future application.
And this is all the references that we used to complete our assignment.